Hello, 3Designers. I'm Josh with St. John, 3Design NYC on the forum, and this is the video demonstration series. Today's demonstration is called Solid Module Fundamentals. This is the third part of Solid Module Fundamentals, and today we're going to take a real close look at Loft. I'm really excited. Loft's a great tool. I get a lot of questions about Loft, so let's not waste any time and jump right into the 3Design workspace. Alright, so let's talk about Loft. Loft is in the Construct toolbar, and so far in Solid Module Fundamentals we've gone over Extrusion, Revolve, Sweep, and now Loft. So Loft and Sweep are quite similar in the way they are approached, but they're opposite. Where a sweep is paths and cross-sections, a loft has more to do with the cross-sections. So let me just get a quick example to show you what I'm talking about. Making a sketch on the top view plane. Going to use cyclical curve and just make, I don't know, 4 or 5 points to make a shape like that. Now I can leave the sketch and I'm going to do a move, rotate, scale. 2 of them actually. The first I'm going to move up and over. Doesn't matter the distance. And the second, I will just move straight up. Doesn't matter how high again. I'm going to hide my axes and planes, and we see that I have 3 curves. 1, 2, and 3. So these are my cross sections, and I want to loft them. So because they're all copies of each other, the starting points and directions are all matching. That's good. I don't have to click on hinting of sections. You should all be becoming familiar with what hinting of sections means. It rebuilds the curve within the function. This is the Sections tab. The next tab is Paths. So under Paths, I have Interpolation mode. I'm going to validate on loose, and you can observe what happens. So notice that this cross-section is not, the loft is not fully realizing or not fully meeting the confines of this cross-section. Let's double-click back in, change interpolation to normal, and see how that changes things. Now you see all of the cross-sections are met exactly. And then the final interpolation is straight. And that's what a straight interpolation looks like. Now let's make this a little bit more confusing, and we'll go ahead and put a sketch on the front view plane. And now I'm going to put a curve with 4 points there, and another curve with 4 points here. So I'm actually going to delete this loft, exit the sketch, and delete this loft. And now I'm just going to loft this one and this one. Okay? And we'll set the interpolation to normal. And that would work just like an extrusion. But now let's see, we have optional guides. Put that guide, you can have up to 2 guides, and that guide. And validate. So Loft is kind of tricky to understand exactly what's going on. These guides are not paths in the same way that a path is for a sweep. Because if I was to sweep these two, I'll hide this to give you, if I was to sweep that, the cross section is going to be sized exactly to fit the path curves. Loft is different. Loft, it's going to use the cross sections, and then if I do choose optional guides, it influences the interpolation by the shape of these curves. So I suspect that this is clear as mud to you at this point. So why don't we go ahead and do a few examples of practical scenarios, and then maybe it'll make a little more sense. Okay, so I'm going to start anew. And I'm going to place a stone on the top view plane. We'll do a cushion, and we'll go get rid of keep ratio, make it 10 by 10, a square cushion. That's great. Now I'm going to make a sketch on that same top view plane, and I'm going to use cyclical curve to make 3 points. I'm going to turn my grid snaps off by hitting G, and I'm going to size this to fit exactly the stone. Cool. All right, so the next thing that I'm going to do is use the move rotate scale again. I'll hide these axes and planes. I think it's easier to see. We'll use the move rotate scale, and we'll bring this down to, I don't know, like here, and then do it again. We'll bring this down to here, and we'll actually make it slightly bigger, like so. All right, so now I have 3 curves, and they're all copies of each other, and I could choose 1, 2, 3. Loft those. Okay, so this is on loose interpolation, you see? Now we'll change the interpolation to normal. And we get this. And then finally, straight. And we would get something like that. Show my stone. So on its own, that's nothing important, but very quickly I could use that shell command, click on that face and that face, set my wall thickness at 1 millimeter, and boom, there you have it. I made a pretty nice bezel using this this loft. I'll add a chamfer on the inside here, and we get But now let's put a sketch on the front view plane. So I'll select the front view plane, and I'm going to put some guides in for my optional guides. I'm going to go 1, 2, 3, 4. And just like in the sweep, I want to mirror this in 3D instead of in the sketch, because I want them to be parametric to one another. So I'm going to hide my stone, I'm going to hide that plane, and I'm going to step back a few in here so I have my loft again at the top of the tree. Now, if your interpolation is on straight or normal, these guides, here, I'll add the guides in so you can see what they do. It's not going to give me results that I'm looking for. See how it gives almost this faceted pattern? So it's trying to follow the curve, but it also has to match this cross-section here. So if I was to change that to normal, we're going to get the same little bulge here, because it's trying to follow the curve, but it also has to conform to the cross-sections. If I was to change it to loose, I almost get the same effect. So let's do this. Let's delete the loft, and we'll just loft 2 cross sections. This one and this one. Lofting like so. Now we're going to go to normal interpolation and optional guides. Use this as a guide and use this as a guide. Now it follows it. And this is pretty cool because I can go back in here now, and let's say I wanted it to be more like so. When I recompute, I get this effect. I could also come back into my move rotate scale and scale that down. And when I recompute, I get something like that, which is pretty cool again. So now if I was to go back and add that shell to it, 1 and 2 with a 1 mm thickness. And let me try putting a chamfer on here. Let's see if this gives a good effect or not. It does. Perfect. Yeah. Drop the stone in there. And I made this nice bezel. Now I could round out the bottom as well with some 1 mm. So there we have one practical example of when Loft is useful. I'm going to start a new file and show you a few others. Okay, cool. Now I'm going to show you another example of how Loft can fit into a construction. And I have to do a little bit of work first to get there, but I'm sure you'll all enjoy seeing me make a quick split shank. I'm going to use the sweeping wizard. Of course, I'm going to put my cross section in. Something like that is fine. Alright, so yeah, the sweeping wizard is in the jeweler's bench. So I'm going to go click on the path and then choose sweeping wizard here. Add a section. Of course, it'll be the section I drew in, and we can resize it here. Let's make it 3 wide and 2.5 high. That looks good. We'll put a mirror in vertical, so when I move it away from the Z on the sections tab, if I move it here, you see I have the mirror. Alright, so I'll bring that all the way down to about there. Hit a plus sign. That's going to bring it in another section, but it's going to bring it in with the same characteristics as the first one I did. So then I'll use move, and I'll bring it like here. Take a look at what that looks like. I'm actually going to go back down to the bottom one and move it slightly off center, like that. And validate. Perfect. Yeah, so my goal with this is I want to make a kind of crisscross shank. I want it to, if we were to look at it from the top, I want it to come over like that and then over like that. So next thing I'm going to do is cut and delete. Keeping the other side, and do that. You know what? I'm going to put a plane in just to show you how to put planes in. It's down here under support. Bring it up on the Y to maybe 5, and we'll bring it out on the Z to, I don't know, 7. That should give me the cut I need, and we'll make the size of it 15 by 15. And the orientation, it doesn't matter so much for this, but I'll flip it, have it be like so. Okay, now we use cut and delete by a plane. You can also use cut and delete for a plane that you put in yourself. So I can click on the object, and I can click on the plane, and then I can choose cut and delete. And that's the side we want to keep, so it'll cut it right along that plane. And I also want to cut off this side. So I'm left with just a quarter of this shank. Okay, then the next thing I want to do is I'm going to do some surface modeling. We've talked about coplanar edges before, so you should all understand why I'm removing these faces. And then we'll weld this together. and then mirror to the other side and weld the whole piece together to give us our solid. Now it's solid. You can check that in the part doctor with the eyeball. It's true. Alright, so here's where Loft comes in. I'm going to leave the ring size showing, and that's it. So I'm going to extract some curves. This curve here. And I want to do them in two different extractions, so they're recognized as two different elements in the tree, and there. Alright, so now that I have my extract curves, I'm going to hide the body, and I'm going to do a modify to it, and I'm going to change its starting point. Now I'm doing this all in the solid module, so these are my curve tools, which we've used extract curve, we've used extract UV curve, project, link to support, but these are for actually modifying the curve itself. So I can change the origin of the curve, which is currently here. I'm going to put it up just slightly higher like so. And I'm going to do the same thing to this extract curve. I'm going to modify it and change the origin, bring it down to just about there. Now I can actually delete the two extract curves from the tree to limit my tree length as they are right there. And now I'm going to try to loft these two. Extracting curves is interesting. Extracting and deforming, it changes the number of control points that you have. So right now these curves are extremely heavy with control points. So lofting is a bit of a challenge on curves like this. The curves also have to be going in the same direction. See if that matches up. Nope, we're not getting the loft to take. So let's try adjusting these maybe down to there, see if that takes. There we go. Now that is a nice clean loft, and you can tell it's clean because of the number of lines on it. I'll show you a not clean loft in a second. So let's go in and touch on, we want it to normal interpolation. We're also going to use an optional guide. Anybody out there have any guesses on what we're going to use for the guide? We don't have to draw a new curve. It's on the screen. Yeah, we're going to use the ring size as a guide. And watch what happens here. Okay, so now it's going from there to there. Why? The direction of the guide. Switch the direction, and it goes in the other direction. Now, the positioning of the guide is on free right now. So let's change it to top and see what happens. See, it kind of squishes it in on the top. Let's change it to side. Side makes a very nice result. And right gives us some craziness. Now you know when you're lofting that that's not what you're going for. So I would say side was our best positioning now. You'll get more comfortable with what the positioning does. But don't forget about it when you're doing your lofts because it is important. And we'll validate. And it comes in as a solid piece. Now just to show you what would have happened, I'm going to hide the modify and hide the modify, and I'm going to bring back the extract and bring back the extract. Okay, so now I have my two original extract curves, and I'll show you what a not so good loft looks like. So we loft that, and then we'll try just as it is, and we're not getting any result at all. I'll try hitting hinting of sections. And you notice that in the hinting of sections, it's putting the starting point in slightly different places. So now, if I preview what that looks like, you'll see that we have a lot more of these lines across, which will translate into a lot more surfaces. Yeah, sometimes you're going to have geometry that looks like this. It's best to avoid it. We're much happier with this loft here. Okay, and then I can mirror that across the center plane, like so. And I end up with this pretty cool shape. So that's another example of loft. I'm going to touch on one more example, and then we'll wrap it up, and you guys can go off and experiment with this. All right, so I'm going to show my front view plane, and we're going to go to File, New. I'm not going to save that, doesn't matter for this example, and I'm going to create a new part and put a sketch on the front view plane. So I'm going to start off by making just a ring. Size 6 is fine, and then I'm going to put I want it to kind of flare open on the top like so. So let me go in here. I'm also going to put a cut curve down the middle because I only need half. My grid snaps are on. So I'm going to trim away the half that I don't need, like so, and trim away that quarter. And now I can play with, get the tangency correct. Like that should work. And then finally I'll auto connect, and then I will mirror over that segment like so. Great. Now, how do we measure the length of that curve? Well, the best way that I've found is if you look in the properties here, you see we have a little star there. So if you hold Control and hit star, under mine I have display curve direction and display information about the curve marked. So now if I click on it, it tells me the exact length. And I'm going to record that. 45.7. It doesn't have to be exact. It doesn't matter. Now, if yours does not say that, it's because you don't have those two clicked. So you have to go and make sure that those two are clicked. And to turn that off, you just hit the button again. Next up, I'm going to make a sketch on the top view plane. So I'm going to make a circle. And I want to bring it up, I don't know, about there. And then do a circular duplication. Then I'm going to use my trim tool again and go 1, 2, just get the outer ones. That's all I need to get. Then when I do my auto connect, I can just select this all as 1. Now I'm going to leave the sketch, and I'm going to take this and I'll do a move. Anybody guess the length? Yep, 45.7. Bring it up. Validate that. So now I have the two cross sections. I'm going to double click back on the shank outline, and I'm going to draw a curve, a segment, the same length. So 45.7. And then lastly, I'm going to go back to the top view sketch, and I'm going to draw a helix. It's okay, I can just click on a spiral and then I can go back in and change it to helix height and revolution. Height will make it 45.7. Revolutions will make it 8. And radius will make it, I don't know, 2 is fine probably. And validate. So now I'm going to do something kind of tricky. I'm going to take this kind of flower shape and this flower shape, choose Loft. They're copies of each other, so they'll loft fine. Change it to normal, and then optional guide. The first guide I want to choose is the helix. Let's look at what that will do. And then the second guide that I want to choose is that segment. Now I can tell already that it's twisting it, but it's making it rough. So I'll validate. Okay, now you can see the result, first of all, is not solid. And second of all, the twists are not even, but you see where I'm going. Now to fix this, the way I'm going to do it is I'll go into my helix. And let's see, I'll change the number of revolutions to 4. Recompute. And I can recompute right within the sketch to see if it works. And it does. It works really nice. Cool. So the twist worked. It's really interesting to note how this loft works. It actually kind of surprised me the first time I was able to figure this out. So the first one, you have to do it in the perfect order. The first one is the helix, and that sets the direction of the twist. And then the straight line is what holds the twist straight. And you have to really play with the number of rotations and the lengths and all of that to make sure that you end up with a solid. But once you do end up with a solid, that solid is the same length as this curve. And we can use the tool wrap along a curve, and we can do the vertical alignment on the top so that matches the finger size. Validate, and we end up with this really cool twisted wire effect. And it can very quickly be turned into a shank. I can do a taper on it. We'll do a taper with a break. Come down from here. I'm actually going to do it from the top, not the bottom. And I have that break on it. I can change where the break is to here. Turn the smoothing off. And there you see I have this pretty cool twisted wire shank. Alright, so that's kind of an advanced loft, but it kind of shows you the power of working with cross sections over working with the path. But Loft is a very powerful tool, and it's something that all advanced 3D designers should be using in their constructions. It is it does achieve things that you cannot do with sweeps or extrusions or revolves. All right, so that wraps up Loft. Hope you guys have enjoyed it. Hope you gained some insight into Loft, and I hope you're getting a developed understanding of what solid modeling is. Solid modeling, so far we've done revolve, we've done extrusion, we've done sweep, and now we've done Loft. These are the core components that you're going to use to make the majority of the solid objects that you'll then later jewel and make into, final pieces of jewelry. Anyway, as always, I'm Joshua St. John, 3Design NYC on the forum. Get up on the forum, post your feedback. We're so happy with the reception the video demonstration series has received. If you have any questions about anything, get in touch with your territory manager. And until next time, go make some beautiful stuff.